In my last video, I benchmarked the Intel Arc A770 and the Arc B580 using Sycl. And honestly, the A770 looked bad. Not a little disappointing bad, but as a Linux user, I don't really have a use for this card bad. After that video, I was working in Python on other projects and came across the OpenVINO GenAI Python package. I tried an LLM with it, and the results were interesting. Then I learned the OpenVINO GenAI pack includes an LLM benchmarking tool. It's still in development, and it sorta works. I ran Qwen 2.57 billion a few times, and at that point, I knew I had to rebuild my benchmark workflow to match my last video. In today's video, I'm reporting what I found. Let's start by comparing OpenVINO on the A770 using i9-15 to both the A770 and the B580 running Sycl through llama.cpp. In my last video, the A770 running under Sycl was underwhelming, especially next to the B580. But here's a surprise. With OpenVINO, the A770 outperforms both the A770 and B580 running Sycl across every model tested. Compared to its own Sycl results, the A770 suddenly looks like the tensor cruncher it was supposed to be. Using OpenVINO, it's nearly 2.5 times faster on Qwen 2.57 billion int4, and a little over 7 times faster on the more demanding int8 version. Up next, I'll show you the results of the A770 in OpenVINO using the XE driver. I have two reasons to test the XE driver. First, I wanted to see whether the A770 with the newer XE driver and OpenVINO could widen the gap between the B580 and Sycl combination even further. Second, in my last video, someone commented that skipping the A770 with XE drivers was criminal. I don't want any problems with the law, so let's see how the A770 performs with XE drivers in OpenVINO. And with the XE driver in OpenVINO, the A770 widens the gap over the B580 running Sycl, and is consistently faster than the same A770 using the i9-15 driver. While the difference on the chart looks small in most instances, the A770 with XE drivers had a weighted average increase of about 13% against the A770 using the i9-15 driver, which isn't insignificant. It also seems that OpenVINO favors Qwen 2.5 far more than Mistral 0.1. One last thing. For Qwen 2.514 billion, the B580 was tested at 5-bit quantization, while the A770 ran int8. OpenVINO models, available on Hugging Face by the way, are generally limited to int4 and int8, so the A770 wasn't just faster, it ran a more intensive variant of Qwen 2.514 billion than in the Sycl trials. Now let's look at OpenVINO on the B580. The B580 is newer, but it's still a lower tier card than the A770, with a smaller memory bus and less VRAM. So the question is, does it stay within the performance boundary set by the A770 with XE drivers, or does it break through that barrier? With OpenVINO, the B580 consistently outperformed the A770 across the models it could run. The only exception was Qwen 2.514 billion int8, which failed to run on the B580 after multiple attempts. For the models that did run, the gains were significant. All three 7 billion parameter models saw about a 50% increase in throughput versus the A770 with the XE driver running OpenVINO. Qwen 2.57 billion Q4 reached nearly 89 tokens per second. Even Qwen 2.514 billion int4 ran faster on the B580 at about 45 tokens per second, roughly a 19% increase over the A770. I wasn't expecting this. The B580 has 4 GB less VRAM than the A770, yet it still outperformed the A770 in its best OpenVINO configuration. That means the current best of BattleMage beat out the Alchemist flagship. With that said, Intel versus Intel is settled. Now, it's time to move beyond that. This was the most surprising result of the entire test. The Intel Arc B580 kept up with, and in some cases slightly outpaced, the RTX 5060 Ti 16GB across this benchmark set. This graph was not produced in error. These results are real and repeatable. To put that in perspective, the B580 is a 12GB card positioned against the RTX 4060, and priced most comparably to the RTX 5050, while the 5060 Ti 16GB sits much closer to a 4070 or even a 3080 in raw compute capability. In LLM inference, the B580 is clearly punching far above its weight. At $250 MSRP, and often closer to $230, the B580 is competing against a $379 or $429 RTX 5060 Ti 16GB. The performance price gap makes these results hard to ignore. So, the B580 really is the little GPU that could, at least when it comes to LLM inference with OpenVINO on Linux. If you already own an A770, you're not out of luck. OpenVINO gives you competent inference performance. But don't catch FOMO if you don't already have an A770. The right software changes the story for these cards. Right now, Sycl just isn't a great runtime for Arc when it comes to LLM inference. Even though it allows for llama.cpp support, the performance just isn't there yet. OpenVINO, on the other hand, completely changes how these Intel cards behave. It pretty much gives Arc cards superpowers. But OpenVINO isn't perfect. Despite having open in its name, it's mostly developed and maintained by eggheads at Intel, as far as I can tell. You don't really see it show up in community AI projects, and model support is still a real limitation. There's a limited list of converted models. Outside of VLLM, most of the LLM world runs on GGUF or GGUF. OpenVINO needs models converted into its own IR format, and from what I understand, the GGUF to IR conversion requires low quantized models to be converted to int8 or FP16. It seemingly removes the advantage of lower bit quantization, which is what lets you run bigger models on cards with less VRAM. There's also tooling to think about. Intel has announced Project Battlematrix, which should bring a graphical interface for running AI models with OpenVINO. What we don't know yet is whether Battlematrix will work on consumer Arc cards, or if it'll be limited to workstation parts like the Arc B580. Hopefully, it supports consumer cards, because regular people are interested in AI inference too. As for Sycl, I don't think it's fair to write it off completely yet. Sycl is a Kronos Group project. It's trying to support hardware from multiple vendors. That takes time. Also, the Sycl devs probably don't have precise information about the Intel silicon they're trying to get to work. OpenVINO has a huge advantage here. It's Intel first, built by engineers who probably get to understand XE at the architectural level. Sycl's performance today doesn't define what it'll look like in the future. One last thing to wonder is, where would an Arc B70 end up performance-wise? What NVIDIA card would it keep up with while under the influence of OpenVINO? With that, I'm going to bring this video to a close before the conclusion gets longer than the benchmarks. Thanks for watching, and take care.